We're going to get started. My name is Corey Fabian Bornstein. I'm the Public Programs Coordinator here at the NHA, and very excited to welcome you to this week's edition of Food for Thought. As some of you may already know, we've had a bit of a switch up in the lineup for this week and for November 20th. Barbara White was supposed to speak today about Cyrus Peirce, but unfortunately she's suffered a loss in her family and is not on island. So she will be joining us on November 20th to give her talk about Cyrus Peirce. But today, we were very lucky. Our very own curator, Mike Harrison, was able to step in and give the talk that he was going to give on November 20th today. So, perfect timing. I was just going to remind everybody to take this moment to please turn off or silence your cell phone so as not to disrupt the program. So take that as your cue. I also wanted to thank everybody who's here, as always, for supporting this wonderful free community program that is made possible in part by the M.S. Worthington Foundation and receives media support from Novation Media. On that note, I can tell you a little bit more about our speaker today, our somewhat surprise speaker. Mike Harrison has worked as a museum curator and historian for the last 18 years. He's served as exhibitions curator at the National Building Museum in Washington, D.C., as historian and associate curator in the maritime collections of the Smithsonian's National Museum of American History, and as project curator of oral histories and photographs at the Riverside Museum in Glasgow, Scotland. He's been all over before he came to us here. He's curated the forthcoming permanent exhibition at the USS Constellation in Baltimore and co-curated the new visitor center displays at the Rosie the Riveter / World War II National Historic Park in Richmond, California. For the last 5 years, Mike has been associated with the Heritage Documentation Programs at the National Park Service, which is a historic building survey, which you can see an exhibit of over at our very own research library if you're interested. And he's also written extensively about a wide variety of buildings, places, and watercraft. A native of Michigan, Mike holds degrees in history and museum studies from the University of Pennsylvania and George Washington University. Please join me in welcoming Mike Harrison.
Well, hello. Thank you for coming out today. I wanted to talk to you today about some research that I did when I was at the Smithsonian, working in the maritime collections at the National Museum of American History. The object that you see here, alternating with its original patent drawing, is one of 10,000 patent models that the Smithsonian hold in various parts of their collections. Out of that enormous body of objects, about 6 models represent maritime activity and inventions relating to that. When I was working at the Smithsonian, we wanted to use many of these models in an exhibition that we were working on, and it quickly became evident that we didn't fully understand all the models that we had, that we simply had descriptions of many of them, dates of many of them, but we didn't really understand what problems in the 19th century they were trying to solve, who were the people who had invented them, what were their biographies, sort of what was the relevance of these objects. So I received a grant from the Smithsonian Institution's own Lemelson Center for the Study of Invention and Innovation that paid for my time to do research intensively into this collection, to have the entire collection photographed, and to have a website catalog put up, made available, so that all the new research was available to researchers online. And I'm happy to say if you do a web search for marine patent models, the first hit is this catalog. So first of all, let me start by giving a brief introduction to the American patent process in the 19th century. To promote industry and innovation, the first federal Congress set up rules in the 1790s, actually in 1790, that required inventors to submit written specifications, drawings, and a model where the invention could actually be modeled with all patent applications. The purpose of the models was twofold: to allow patent examiners to see how the invention worked, and also to allow anyone to reproduce the invention after the 14-year exclusive period of the patent expired. The models for approved applications were retained and were displayed in the patent office, and this became a very popular tourist destination in Washington, D.C. When the British burned the Capitol during the War of 1812, the patent office was the only public building not burned, because the patent commissioner made a plea out front asking the British if they really meant to destroy so many inventions and innovations. Later, when the Patent Office headquarters was completed, you see the picture there of Robert Mills's completed building. This is the upper floor of the building, and all of those little markings are the cases holding the patent models. Maintenance of this model collection was very costly, and in 1870, Congress removed the model requirement, although many inventors were permitted to continue submitting models if they wanted to, and many did. 10 years later, in 1880, Congress prohibited you from sending in a model. So what happened was, after the turn of the 20th century, the Patent Office began to dispose of models. The Smithsonian Institution was given first choice on at least 2 different occasions to come and remove models, and their curators went there and made a selection. A quite remarkable feat to go there and determine which of all of these models actually were significant enough to retain for the nation's permanent collections. And I must say, I've always been very impressed with the work that was done at the time in figuring out which things to keep and which not. As you can imagine, there are many more inventions that were patented than ever became actually successful and widely distributed. And knowing which of those are which can be quite a challenge. So moving on to a bit more context, maritime activity was vital to commerce, communication, and communities in America in the late 18th and early 19th centuries. Its importance here in America created a fertile environment for citizens to suggest faster and surer ways to deliver people and cargo across the ocean and over the nation's expanding network of inland waterways. The models that I studied largely dated between 1850 and 1880, and they divide into a number of broad categories of inventions. First, a selection of things related to navigation. So patent logs, compass improvements, sounding devices, fog signals. The 3 things we see here, the bearing indicating fog signal, you turn the dial on the front to indicate which way your ship is pointed, and then as you activate the bellows on the inside to make the fog sound, it automatically does the sound in a certain pattern to indicate which way you're going. The idea, of course, is that any ship that hears you has to also know what those things mean. This system was actually endorsed by the British Board of Trade and a number of other bodies, but never reached wide distribution. There was never international agreement on a system for it, but there's the patent model showing how it would have worked. The deep sea sounding apparatus, this is again a way to determine the depth of ocean under a vessel moving at a high speed. That was the particular thing about that invention. And the ship's log is a more traditional way of determining a ship's speed. This is one improved by a British maker, and the British maker applied for an American patent to protect their investment. The collection also contains a significant number of models related to vessel construction, new framing and compartmentalization techniques, ways to use new materials such as iron. Iron shipbuilding, can you apply the traditional wooden approaches to pieces and components, or do you need to come up with new ones? Model measurer, that's the device up here that you see for taking measurements off of ship models in order to build full-size ships. And paints. The bottle is a patent model of paint. Although, I guess to use it, you got to actually apply it to something. A significant and fertile area for invention came in propulsion. Numerous propeller and paddle designs speak to the immense international effort to introduce steam propulsion in the 19th century. The collection that I was looking at contains improvements to steam engines, steering gears, rudders, as well as propulsion devices. A number of these can be rather fantastical. The 1841 example here is kind of like duck paddling underneath the boat. The 1871 example on the lower row, there are many blades here that turn automatically as they come into the water. The idea is to try and reduce the amount of drag as the paddles go into the water. That's the same thing going on with the 1877 example, where this beautiful metal model, all of those blades are supposed to enter the water straight and then turn and propel the vessel. It's probably actually not that efficient, but it makes for a beautiful sort of device. And then the one in the upper, the 1854 example, is a suggestion that you actually put the paddle wheel in a trunk in the center of the vessel, and that might make it more efficient. That was not done terribly often. Life-saving is a big category. in this particular collection and was quite the interest of many people, as we'll hear a little bit later on here. Many lifeboat and life-raft models, of which we'll look at a few more more closely. Interesting thing here, the lower right 1874 model, much of this boat is filled with compartments. And at first glance, you might think, well, these are all air-filled compartments to provide buoyancy. And that's part of what this inventor had going on. But in addition to that, the novelty of this particular invention was that when the boat was launched, certain compartments in it were meant to flood with water and provide ballast to keep the boat stable, while other compartments and the rubber fenders that you see around the bulwarks were meant to provide buoyancy. Again, the idea didn't necessarily have to be super practical, it just had to theoretically work. So I don't know of any actual ships adopting this particular device, but they spent a lot of effort building this beautiful model to demonstrate it and then to display that in front of the public for many years at the Patent Office. So who do we have actually inventing things? That was a major component of the research that I undertook to try and understand who these people were and fill in some biographical details so that when these objects were presented to the public, when these objects are used in exhibitions, we can actually say something about real people solving what they perceive to be real world problems at the time. Some of the professions and backgrounds of the inventors in this represented by this particular collection are just as we might suspect. Others are more of a surprise. Unfortunately, all of the models that I looked at were all invented by men. There definitely were women inventing and getting patents in the 19th century, but none of them happened to be represented within the selection of models saved by the curators at the Smithsonian in the 1920s. Here we have an example of the many inventors who were professional mariners, who in the course of their everyday work came up with ideas and then applied for patents to protect those ideas. This is Frederick Slocum Allen, born in 1837. He lived in coastal Massachusetts. In his childhood, his family made their home on Cuttyhunk, where his father worked as a pilot. Frederick assisted as a boat keeper during his youth and into his 20s, and then in late 1856, he embarked on a whaling voyage, which went to the Arctic. He was gone for 3.5 years. One biographer noted that during his 30s, Allen, quote, spent considerable time and money in improving windlasses, and he has given special attention to the saving of life from shipwreck. And in 1887, at the International Maritime Exposition at Havre, France, he was awarded a silver medal for a reversible lifeboat. The 1880 census lists him as a farmer, and for many years he served as a justice of the peace. These are the two inventions of his that are represented in the collection, one being, just as the man described, an improvement to windlasses. This one, ordinarily with these windlasses, you would take a pole, stick it in, and exert pressure on it to turn it. This inserts a number of gears, hoping to make that process a little less arduous for hand labor. And then the reversible life raft, these are buoyant casks attached to a framework, and it can be launched either way. So if you throw it off the side, it doesn't matter if you kind of get that wrong, as might happen in an emergency situation. So then engineers, many engineers in the course of their professional existence are applying for patents in the past, just as they do today. Frederick Sickels was a particularly well-known American mechanical engineer who's devoted a significant portion of his collection to improving steam engines and advancing their use at sea. He held numerous patents, but is best known for developing the first successful steam engine cutoff valve, which was patented in 1842. The Smithsonian does have models for that there in the railroad collections. He was particularly interested in developing steam-assisted steering, which was also a topic dear to many other inventors, as ships became larger and heavier during this period and more difficult to manage by manpower alone. The two models shown here demonstrate Sickels' idea for a steering apparatus where steam pressure in a pair of cylinders would control the side-to-side motion of the vessel's rudder, as well as hold the rudder stationary against the force of the surrounding water. The interesting thing here between these two dates, it's the same invention, just improved, and he applied for an improvement patent. The 1853 model obviously represents the entire vessel, and shows not just these sort of interesting metal cutaways of the steam cylinders at the helm, but then how that connects down to the rudder. So it makes a direct visual connection for the examiner of how this fits within the vessel. By 1860, he didn't feel that that was necessary, that all he needs to show is how the cylinders work at the helm itself, and those other connections are left into the description. It shows a sort of interesting thing about sort of development of an expectation about what your patent examiner can imagine for himself as you're putting an invention in front of them. And many of these models, I should say, are beautifully made. I mean, and there were professional model makers that people would go to. Some people built their own, or had local workshops build them. Others would go to professional makers. But the workmanship and craftsmanship in many of these objects is quite spectacular, and they make some of them quite sculptural. Others are just very fine examples of woodworking. And also, sort of interesting here as a presentation model, the 1860 model, the wheels on a ship that might have used this apparatus would have been wood as traditional, but the steam cylinders wouldn't have been. This all would have been done in metal. And so it's fascinating to see the model created in wood in order to create a presentation piece. So I rather like that. Moving on to other examples of people represented within this collection, we have Elisha Barlow, who was a machinist and engineer in San Francisco. Let's see, my notes here. Technically skilled craftsmen frequently patented things. And we see many examples of things from locksmiths, mechanics, carpenters, carriage builders, and not always suggesting things within their particular professional field of view, but applying the skills they had into other fields where they thought that would be helpful. Here we have Elisha Trask Barlow, whose craftsmanship is quite evident in this model, which he probably made himself, showing an improvement to anchors, obviously. And this anchor has two shafts, which help the flukes to burrow in, and then also allow, by certain arrangements, for you to actually get the anchor out of the muck when you want to sail away. Here we have another engineer who some of you may have heard of. This is the Scottish physicist and mathematician Sir William Thomson, who was later made Lord Kelvin of Largs. The Smithsonian collection, he spent a lot of time looking into different things. He was best known for electrical inventions that were used in laying the transatlantic cable in the 1850s and 60s. And those inventions made him quite wealthy. And then later, as a professor at the University of Glasgow, he spent summers on his yacht sailing around doing experiments. And these devices come out of the experiments that he did on his own yacht. The Smithsonian's collection contains important patent models from Scottish and English inventors, as well as French and German inventors who took out US patents. Although, well, I should step back and say French and German inventors certainly took out US patents. The Smithsonian collection doesn't have any from them. It's a little biased more towards the Scottish and English inventors. So what we show here again is the deep sea sounding apparatus that we saw earlier, and then the binnacles. Kelvin is among the first to devise ways to compensate compasses on ironboard ships. The hull iron and steel in a ship will interfere with the compass, and you have to correct for it in particular ways. And he devised a binnacle with iron balls that worked this way and various calibrations within it. Interestingly, the Smithsonian's collections have two of these binnacle models, which you see represented by the two photos. One goes with the patent for the compensating binnacle. The other goes for an improvement to the compass card that sits in the binnacle. One of them is in the maritime collections. One of them is in the mathematics and science collections. They came in through different avenues, and until we did this research, nobody realized we had two of them representing different aspects in Thomson's career. And obviously the picture is really nice because he's standing at one of his own binnacles. So always look at the maker's marks on binnacles when you see them and see if it's a Thomson compensating binnacle. It will not be a surprise to discover that numerous patents were taken out by people involved directly in shipbuilding, boat building, and the allied trades. Here we have two examples from the Pittsburgh steam engine builder James Rees, an invention for a capstan and for a rudder. Rees was a prominent owner and builder of river steamers, and his firm supplied engines for many vessels on the Mississippi, Ohio, and Missouri river systems. He is credited with helping to popularize the use of stern wheels on the western rivers And the rudder design we see here is a direct response to the requirements of stern propulsion. It's a little bit difficult to see, but the center of these three rudders is cut out in a bit of a curve. And so if you imagine this being installed with, well, actually the wheel would actually be behind it. There are all these various curves, some to adjust to the shape of the hull and some to adjust to the shape of the wheel going behind the vessel. The capstan that we see has gearing aimed to prevent faults caused by the hogging of shoal draft vessels. Again, a particular challenge to riverboats on America's rivers is they're built very shallow, and they're built as big platforms, and because they're made of wood, they tend to hog, and the ships would often be built with elaborate cable stay systems to try and hold themselves up by their own bootstraps. And because the hulls would hog over time, this would cause problems with the mechanical systems in them, capstan being one of them, and this is a design in response to that, developed by somebody directly involved in building these kinds of vessels. Rees and his wife were both Welsh immigrants, and many patentees were in fact immigrants, including Jacob Eckert, joiner of St. Louis. And here is from his published patent description, where he proudly proclaims that he is a citizen of the United States. In many of these patent descriptions, when they say particularly that they are a citizen of the United States, it often means that they are an immigrant, and they've come here and are very proud of this. Eckert patented a number of devices in his life, and you can approximate the date of his naturalization by the appearance of the word citizen in his specifications. What's particularly revealing about this is that Eckert seems to have perceived that taking out a patent was not just a financial investment, but it was a way for him to shape his identity and claim community status. If you could raise the $30 required to apply for patent protection, you could materially contribute to the progress of the nation and thereby become more American. This seems to have been a current idea in many people's thinking. And we have models that then represent that. This particular propulsion method, there are chambers that pass through the hull of this vessel. This is seen from the top, obviously. And the idea is that you force water by plungers through these two channels and use that as a way to propel the vessel forward. This gets around problems of paddle wheels and propellers snagging on various things, but does not seem to have been practical. I don't know of any vessels that actually use this. So, as well, clerks, bankers, merchants, financiers, lawyers, other educated professionals who didn't necessarily have a substantial amount of vocational training or vocational connection to mechanical matters, many of them took out patents. Very often, these people seem to have done so more, again, for status, the status of holding a patent, than for any technical merit of their inventions. This particular man straddles the line between these two extremes. In 1849, he was a 40-year-old lawyer living in an inland river town, and he saw firsthand the seasonal difficulties of low water, shifting sandbars, and floating debris, and the challenges these pose to vital inland water traffic. He suggested a solution, represented by the model you see here: inflatable rubber cloth chambers that could make boats more buoyant on demand. Now, it didn't necessarily work, but it's kind of a fun idea, is that you could lower these pontoons, and it's not that you're going to hoist your way across, but you can lower them, fill them with air, it makes the ship more buoyant, and hopefully it will sail off of the sandbar that it has come upon. Now, many of you may already recognize who this man is. This is Abraham Lincoln. So the only US president, although he wasn't president, only future US president, to hold a patent, and the Smithsonian has the patent model. In fact, they like the patent model so much, they also have a copy of it, because there's demand for displaying it in many things. But a really interesting thing that you take out a patent because you had a good idea and because it was possible for you to do that. And you didn't necessarily have to have it related to your profession. By the way, this patent is obviously taken out 11 years before he becomes president. Here we have an example of the type of situation that Lincoln's patent was aiming to address. And he personally would have been familiar with the difficulties of river navigation, and would have seen the very real life-threatening dangers posed by some of his day's developing technologies, particularly boiler explosions and fires that plagued mid-century steamers. I imagine he would have agreed with an 1838 magazine writer who said, quote, In truth, the accidents involving destruction of life and property have become so frequent upon the western rivers that we look as regularly when we open a newspaper for a steamboat disaster as for the foreign news. It's not that storms and collisions and disasters at sea were new, but there was a rising awareness of them, an ability to learn about them more quickly, and there were more people at sea, increasingly in the 19th century, who were not mariners than had ever gone to sea before. The patent models in the collection that I was looking at suggest that something new was developing in the 1800s, and they suggest, as I was just saying, the emergence of a more widespread safety consciousness and the translation of that consciousness into a popular desire to prevent accidents and better equip people at sea to survive the dangers that might come their way. Increased trade and passenger traffic placed ever greater numbers of people at sea. There were more sailors, certainly, but it is the rise of business travel, social travel, and especially immigration that swelled the numbers of people on the water. Significantly, these new travelers were not professional mariners. They were not expected to have the skills necessary to respond to an emergency, nor to be able to fend for themselves if left adrift in an open boat. And I should say also that increasingly, with the rise of more steam-powered vessels, fewer and fewer members of the crew of a vessel might be expected to fend for themselves if left adrift in an open boat. If you're trained on a sailing vessel and you crew a sailing vessel, almost any man on that vessel can be put in a boat and know what to do. But if you're on a steamship, you can't necessarily expect that your steam engineers will have had the training in sail that the deck people might. And you certainly won't expect that your catering staff or your salon stewards, if put adrift in an open boat by themselves or with 20 or 50 passengers, would be able to get their way to land. In addition to more people being at sea, there's also, and this obviously has impacts in many areas beyond just safety at sea, the rise in expansion of ways of communication really also have an impact here. Find my way again. Technical and popular presses flourished and expanded in the 19th century as new technologies increased the volume and speed of periodical and book publishing and increased the amount of illustrated content in these media. And then we see, the connection of technologies. Railroads, the telegraph, packet ships, steamships, these all increased the speed at which news traveled, providing new immediacy to accounts of all kinds. The cumulative effect of this, and so here we have an example. Steamship Cambria, a Cunard liner, arrives at Boston with all the latest news. And particularly in the 1850s, you read in the newspapers, the foreign news is often tied directly to the vessel it arrived on. They don't just say it's the latest dispatches. They're like, the latest dispatches from the Cambria tell us. And you see this, the news is only a week old, is only 10 days old, and how remarkable that is. Here we have, carrying this example further, if you can publish charts showing the extent of shipwrecks or making a big deal out of them, that's going to change people's perceptions of what's going on. And the cumulative effect for our purposes was an increased perception of accidents, disasters, and rescues at sea. Not necessarily more disasters, but different kinds and a more immediate awareness of them. The map on the left here is from 1887 and shows known wrecks on Sable Island off the coast of Nova Scotia. And the two news items are from the New York Times, 1854 on the top and 1851 on the bottom. An 1869 writer in the Atlantic Monthly summed up this situation. Serious and frequent disasters involving large sacrifices of property and of human life have lately directed public attention to the imperfect guards against accident and to the inadequate means of rescue which are maintained in this country. But though we neglect the preventative measures, American inventive genius has been largely directed to the construction of various machines for rescuing endangered life and property. This is from F.G. Shank's Life-Saving as a Business Duty from the Atlantic Monthly. So returning to the models, here we see people responding to this very kind of situation. This is boat builder Joseph Francis. He experimented with boat construction methods throughout his life and is best known for inventing corrugated sheet iron boats in the 1840s and 50s. He claimed, and he published a lot of material on this, that his boats were indestructible, economical, and impervious to rot and decay. Here we see a patent model, very fancily painted, showing a stamped metal boat and how it would be assembled, and then one of his own, from his own promotional materials, the type of steam-powered press that would make these components. It's a hydraulic press, actually. And the model is from 1858, as it says. Through a collaboration with the Novelty Ironworks in Brooklyn, New York, he began to manufacture lifeboats, military cutters, and coastal rescue craft, as well as life preservers and similar gear in the 1840s. His products proved popular among commercial steamship operators, life-saving stations, and the U.S. Navy. The Collins line of transatlantic liners adopted Francis lifeboats for its express passenger steamers in the 1850s, and when the SS Arctic sank with great loss of life in 1854, its patent metallic lifeboats survived, and the company ordered more boats for its remaining ships, which didn't keep it from going out of business by the end of the decade anyway. Nevertheless, Francis was moderately well known in his day because his boats did in fact work and did save lives. He is remembered best, however, for this machine. This is a life car, and any of you who've been to the Life-Saving Museum here will see a later generation of this hanging from the ceiling. Many US life-saving stations were equipped with a metallic life car. They all descend from this life car. This is Francis's prototype, and the first one that was used. It was put on Squam Beach, New Jersey, and for use, it was sort of a you'd use the the gun, the way a breeches buoy works is you shoot a gun out to a wreck, and then one man at a time you bring people back in a sort of buoy breeches thing. This takes that idea, but instead you put the people in this car, and you run this car out along the line as shown in this dramatic print. This print is from an advertising piece, by the way, which shows beautifully arranged in the foreground Francis's other boats available to you while the life car rescues people off of the wreck. This prototype did factor in a wreck, as it says. The Ayrshire, which if you read some news reports, they may have just found the wreck of the Ayrshire on a beach in New Jersey this week, was a British bark carrying immigrants. Like many barks and sailing vessels in a storm, it missed the entrance to New York Harbor and ended up on the coast in New Jersey, ran aground, and they decided to use the life car to rescue people. All but one of it's either 201 or 202 people aboard, depending which account you read, but all but one of them were saved. The one person who was not saved was a man who did not want to be separated from his family, who were put in the car, and he didn't really trust the thing anyway, and he tried to cling to the outside of the car when it was towed back, and he was swept away. Everybody else was rescued. So we then see there's later generations of these at other life-saving stations, but a fairly significant thing, and a direct outgrowth of Francis's experiments with doing metallic pressed metal boats as both an efficient way and a cheap way to build things, but also something that was purportedly indestructible. So between 1790 and 1873, the US Patent Office granted 163 patents for an amazing variety of life-preserving boats, rafts, buoys, and other gear. In a clear response to the rise of passenger travel, many of these inventions expressly aimed to remove sailorly skill from the safety equation. This raft, for example, was the work of fisherman and boat builder George Clark, who lived in Ecorse, Michigan. He would have been personally aware of the dangers of Great Lakes shipping. A contemporary compiler of accidents on the lakes noted that in the year 1871 alone, there were 1,167 marine casualties on the lakes. Of this number, I have here from a press report, 225 were caused by collisions, 280 vessels went ashore, 81 were burned, 26 capsized, 19 foundered, 182 sprang a leak, 65 waterlogged, 60 were dismasted, 110 lost deck loads, and 10 exploded their boilers. That's a typical year. So here we have Clark writing his justification for the patent for this raft. It is the design to have these rafts kept on the hurricane decks of steamers, whence they may be readily thrown into the water by one or two persons of ordinary strength, thus avoiding the delay and uncertainty of working falls and cranes in launching boats. Both sides of the raft being alike, it makes no difference which side is up when thrown into the water. In other words, no skill needed, anyone can use it. Similar to the one we saw earlier, Mr. Allen's with the 3 barrels. Here we have a construction method from A. John Bell. We don't know much about Bell. I was actually able to find a great deal of biographical information on many of the inventors, but Bell was not one I learned too much about, except that he was from the river port of Ashland, Kentucky, and he devised this model to, quote, furnish a safe and reliable means of saving life in case of shipwreck by collision or other accidents. He specified that the upper deck of a vessel be constructed with very high bulwarks. This upper deck would be fixed to the vessel's hull in such a way that when the hull sinks to the deck will float away, carrying the passengers and the crew with it, and thus saving their lives. Similarly, this shows you how this works. So it comes apart. So the top part floats away, the middle deck also floats away, and the rest of it is left to sink. The middle part is obviously a watertight tank. The model, I mean, this is one where, again, I don't suspect this man was terribly involved in actual shipbuilding, since his boat is a bit toy-like, and the idea is extremely impractical. But nevertheless, he's thinking about what could we do that removes skill from the equation and allows parts of the ship to survive in case there's an accident. Mr. Bell believed his invention applicable to all steamers and sailing vessels, both on the ocean as well as on inland lakes and rivers. This universality no doubt contributed to the almost toy-like generic appearance of the patent model. Relatedly, here we have Francis D. Lee's Life and Treasure Buoy. Lee was a well-known architect in Charleston, South Carolina, and with this invention, he envisioned a shipboard water tank that would float free of the sinking ship if drained when the calamity happened. So what we have, so it's like a deck house with a tank below it. And when the ship comes to some accident, somebody rushes below, pulls out stopcock, drains the tank, puts the stopcock back in. Everybody goes back up on deck. They cling to the sides. You see the railing and the wooden piece of deck that goes around it. And it floats away. Now, he later, and then should it actually sink, heaven forfend, there's a flag on the top attached to a buoy. And that will detach and show you where it is. And the thing at the bottom, below the water tank, the little, whatever that square thing at the bottom, that's the safe that holds your valuables. So your valuables go with you when you float away, and if that all comes to grief, the flag tells you where it all is. He did an improvement to this. Let's see if I have the year here. I don't have the year. He made an improvement to this patent where it was possible to pull out the stopcock from on deck instead of going below. And then one of my favorite stories with this particular object, this model had been in the Smithsonian's collections for many years, and at a certain point, many of these models were brought out for a display, and they brought out a beautiful old oak cabinet, like the ones that may have in fact been one of the ones used at the Centennial Exposition in Philadelphia. And they displayed them as if they had been on display there. And so it was just models and tags, like this tag that you see, without explanation, just the way you might have seen in the 19th century. And because this had always been described as a life and treasure buoy, people thought it was literally a buoy. And many buoys, and nun buoys, are sort of conical on the top. And they displayed this with the pyramidal side up and the other side down. And that's how and when we took it off exhibit, we stored it that way, and it's a life and treasure buoy. And it wasn't until I looked in the patent record and saw this drawing, I'm like, oh, we've had this upside down for 20 years. And then, of course, the story of it is just even more remarkable than the fact that we had it upside down, the fact that somebody thought that this was a practical idea. And not just anybody, this is, Francis Lee, who's a, well-known architect. He goes on to take an active part. He becomes an engineer with the Confederate Army during the Civil War and plays a central role in the development of spar torpedoes and torpedo boats. So he kind of knows what he's talking about. I don't know of any ships that adopt this, but it really is a remarkable idea. So finally, this brings me to a significant aspect of life-saving invention that the Smithsonian curators in the past didn't collect, either because the models didn't survive or the models didn't catch their attention, or they figured these were inventions that perhaps don't need to stand the test of time. And that is, like Lee's float-away water tank, An amazing number of life-saving patents aim to imbue life-saving qualities into domestic fittings of life at sea. So here we have a representation of some of these. Again, keyed to the rise of passenger travel in many ways. The life-saving garment, we also have life-saving bedsteads, berths, buckets, bucket rafts, buoys, capes, chairs, stools, dresses, doors, garments, hammocks, mattresses, trunks, and the life-saving hat. I like the mattress one. He looks very calm in a storm. While some forms of life belts and vests grew into legitimate safety devices that enjoyed widespread use, I have not been able to determine whether any of these novelties that you see here actually met with any kind of commercial propagation or success. What's important about them, I think, is that they demonstrate the increased awareness of the need for rescue devices in the changing world of maritime activity in the 19th century. At the same time, they amply show that anyone could participate in the technological problem solvings of the time. Ordinary citizens had subscribed to progress and believed that technology could solve problems, and they could and did involve themselves in shaping that technology, or at least inserting themselves into the conversation. Not that we see any of those things in use here. Just to say, as I said, this was grant-funded research work. There were 70 objects that I studied and that we wrote up. We did determine that a number of things that had always been considered to be patent models were in fact not patent models. They were simply models of a certain size. Other things, models that had come in and had become divorced from any connection to what patent they related to, we were able to track a number of those down. And for many of them, we found a substantial amount of biographical information and tried to describe them all around what's the problem being solved, who is this person, what's the larger context for these things. This is all available on the website. So the Smithsonian Institution, America on the Move, was the project that redid the main transportation halls there. And the website for that has a significant collections portal. This is done as a thematic tour under that portal. And this is just the opening screen for it. But should you be interested in learning more about any of the models I've shown here or seeing a more holistic view of the whole collection, all of the research I did is available there at this somewhat kludgy URL. But again, you can just search for marine patent models, or even my name in marine patent models, or some combination of that, and you will quickly come to it. Are there any questions? Oh.
A Nantucket captain, I think his name was Eyre or Dwyer, is credited, or I thought was credited with the invention of a pontoon, camels, to get over the bar.
Mm-hmm.
And you spoke of another gentleman who had thought about this. Could you make that connection?
Well, so the camels used in the 1840s to try and get whale ships over the bar at the harbor here is basically a type of floating dry dock. The Lincoln patent, which I think is the one you're referring to, is, again, it's an invention about buoyancy and trying to use buoyancy to lift a vessel up. But there, the vessel would carry its own inflatable bags, basically, and they would be inflated and lifted. It would increase the buoyancy and lift it off. One could imagine that theoretically being applied to a whaling vessel, although it would be somewhat impractical to mount those kinds of things for a 5-year voyage and then have them survive long enough to get you across the bar. What I think is remarkable about the camels really is this idea of the floating dry dock, of which there are definitely earlier examples in Europe. That you bring the ship in, close it around, and raise them up. But in that way, they're quite distinct. The vessel carrying its own means of relief versus encountering that at the harbor that it arrives at.
Thank you very much for that talk, and really interesting. And I'm not sure if this is quite in the scope of your research, but one of the big maxims in political theory, market theory, is that innovation is driven by the market, and more often the needs of wealthy and often white people, at least in this country. And in your research, did you notice any connections between that? I mean, I think you hinted a few times, but between a shipwreck where a number of fancy people are lost at sea, and all of a sudden there's a great rush for better pontoons or things like that. And I guess likewise with the rise of air travel, which is 20th century, obviously, whether the ship patent rush kind of fell off, or just if you could speak to that a little bit.
The patent atmosphere changes and becomes more complex in the 20th century. And so none of the research I did looked very far into the 20th century to see sort of how that pattern might have changed as air travel emerged. So I don't have any information directly about that. The pattern as far as, awareness of, is it wealthy people or immigrants or whatever, there definitely is an increase in interest when sailors, the sailing community, well, the professional mariner community are often, it's easy to forget that they're out there. It's easy for them to be marginalized. The work they do is difficult. It is out of public view. Oftentimes sailors come from different types of communities who are not politically advantaged. And you definitely see that once people who are not sailors are more in this equation, there's more attention paid to it. And how that then plays out, if you take that group of non-sailors and parse it out into the wealthy versus the immigrants, I didn't look into that question specifically. I think there are certainly two impulses going on. You see, the inventors often looking for an invention that they can sell that will make them money, and sort of what's the realm in which that they could get that kind of traction. But there's also a humanitarian impulse that, people are not ignoring the fact that immigrants are at sea and that there are, it's just more numbers of people at sea. But something like, a Collins liner in the 1850s isn't carrying immigrants. It's only carrying people who can afford that very expensive experience. And so in that sense, the fact that Collins Line is interested in Francis's metallic lifeboats, it is a part of their, we're going to offer you really good food, we're going to offer you opulent cabins. These are two things the Cunard Line and other, the other British lines at the time are not banking on. They're not doing that. They're saying we're going to get you there safely, and we're going to keep our mail contract. And the Collins Line is like, oh, we can do that better. We can keep our mail contract in the U.S., and we can make this luxury experience, part of which is the safety gear. So I think there's more research that could be done there, but the definite part of that I have seen is this idea that sailors are often ignored in this kind of popular look, and that as soon as the sailors aren't the important people in the picture, oh wait, we've got a problem, we need to solve it. And I see a lot of that happening here.
Hi, I'm Lee Saperstein. I can give you a little more numbers on your answer. Between 1997 and 2004, 640 commercial sailors and fishermen lost their lives. The National Occupational Research Agenda is looking at stability, because half of those people who died were from capsizes or sinking, primarily in fishing boats. Other than the Costa Concordia, I would have to say that sea travel is a lot safer than it was in the 19th century. But survival of the victims is a big issue, and of course, stability.
Yeah.
By the way, a quarter of the fatalities were people being washed off the deck. So attention is being paid, and the Coast Guard is certainly interested in research that will improve stability.
Yeah, well, thank you for that. Yeah, and that reminds me, I mean, in the 19th century and early 20th century, fishing boats out of Gloucester, and the demands of the market of being able to bring fish in quickly, and led to the development of fishing schooners that were very fast, but also very, very top-heavy, very tippy, and led to, contributed significantly to the loss of life in the Gloucester fishery. And a number of shipbuilders, tried to address that and design vessels that were safer, but had some of the same performance characteristics that the fishery felt they needed to meet their market demands. It took a while for these to pay off, for people to actually adopt these designs, but there was a lot of that, and it reminds me of some of this kind of thinking.
As you approached your research, how did it categorize for you, or did you have this in mind that you were going to be looking at it, or as you were overseeing it? I mean, you've gotten it down to a very narrow range, and it's fascinating, but it had to separate the men from the boys at some point.
The project began by trying to understand a group of museum objects more fully, because we wanted to use a selection of that group of objects for a long-term exhibition. And the overall scope of the research was, what are these objects? What do we know about them? What can we learn about them? Out of that, various patterns emerged. This talk looks specifically at, highlights the life-saving aspects and some of the historical trends that these objects suggest about life-saving, particularly. The collection as a whole, as I sort of briefly introduced, looks at navigation and construction techniques and all kinds of inventions related to maritime activity. And the research project did not start out looking to answer questions about life safety. It looked to solve questions about a particular collection. And from that research emerged, oh wait, there are patterns that we could see here about this particular topic. And presenting all 70 objects in the collection, although I could talk for 2 or 3 hours, which would either be fascinating or deadly dull. So that's sort of how this emerged from that start.
One more from Ralph.
Okay, so vessels built out of wood, which have a keel and members above that, the center of the vessel tends to be more buoyant than the ends as the timbers decay, and they go like this, and it's called hogging. If they go like this for some reason, it's called sagging.
All right, great, thank you. I hope you'll all be able to join us on November 20th for the rescheduled Barbara White talk, but for now, thank you so much, Mike.
Thank you, everybody.